What's going to happen is you'll spend 3 days here in the classroom with Joan setting up what polyhedrons are about. Okay? And then you guys on Monday, Tuesday, and Wednesday of next week will come and work with an artist, with the choreographer from Minneapolis. Her name is Marylee Hardenburg. She's an expert in a thing called space harmony, which is a way of looking at dance in the architecture of the body and how the body fits into space.
We're going to be working with objects and we're going to be manipulating them and finding things out about polygons. They all have the same measure for each edge, which means we can build with them. We are going to build a polyhedra. One of them is called polyhedron. More than one is polyhedra. How many polygons do you need around a point to close up space? So 5 times 60 is 300. You have fewer degrees.
Oh, okay.
So what happens when you have fewer degrees around a point? Fewer than 360?
You get more of an angle.
Comes up, does it?
Yeah.
Right. Okay, good, good. I want you to take at least one of the polyhedra you have made. And I want you to think about what you did with it. How many faces are there on it? Which polygons did you use for the faces? And what configurations of polygons do you have at the vertices? What do we need for regular polygons? Are these equiangular? No. So that's a parallelogram, but it's not a square. So it is not a regular polygon. So not all your faces are regular polygons. What else does it meet any of the other requirements? There are 3 requirements for a regular polyhedron. We're going to start looking at those and making those. We're going to find out how many regular polyhedra there are. Okay, pick a vertex.
This one.
Do all the same faces meet in the same way?
Yes.
How many meet at that point?
3.
How about another point? The
3.
same?
3.
It can never be
All
more
the
than 3.
same.
They're all the same.
You've got a regular. What about this
Good.
one?
This is all.
Eventually they were to see that to produce the platonic solids, which are the regular polyhedra, they had to follow the guidelines of the definition. What were the pieces that were there? What could they use? What couldn't they use? And what difficulties did they have? They were to work through constructively and inductively through experience what were we restricted to, and then step back and look at it and say what was really restricting our ability to produce more. Can you put 6 triangles around a vertex?
No.
Why not?
It'll make a hexagon. It's bigger than 360 degrees.
And
It'll
it's
just lay
flat. So you know that with the triangle, how many regular
Oh, it's because it can't be bigger than 360. That's why the triangle you can make so many. This one you can only make one. Why are the bottoms all missing?
losing them.
There. This one makes 360 degrees, and then this one because if you can't make a hexagon one any bigger, then you can't do a pentagon one bigger than this because of the fact that it would exceed too many degrees.
How many of you have found all that you think there are of regular polyhedra? How many did you find?
5.
More than
You found 5?
If there's 5, there's
How many did this group find?
5.
Okay, anybody find more than 5?
Hold on, I'm working on it.
Okay. All right. What did this represent the last time we did this?
Coordinate.
point of 0, 0.
Oh, are we doing that again?
Yes. Now, but since we are doing 3-dimensional work, we have a 3rd dimension to trace into. This is our x-axis. This is our y-axis. For our 3rd dimension, we're going to go up, right? We're going to look for places in space.
Okay, what is it? 32.
Make sure you're going perpendicular. Remember, a perpendicular line is straight.
Or your left foot's going to be right here.
43, hold it up right there. It needs to be 16 here. So you need to hold it, or tape it maybe just down on 16 inches and just hold it up.
Do a 29 up now.
29 right here.
We're going to play a little game called statue. Now, you get to choose one member to be your statue. In each group, you will have one statue. The statue will do what a statue does, strike a pose. Want, and what the other members of your group will do is take the points, it's like your hands, your feet, and figure out where all these pieces are. Then what we're going to do is we're going to switch these sheets. And you're going to have to recreate someone else's statue based on just the coordinates you've been given.
He has longer legs than you.
Emma! Emma! Is this right?
Come on, everybody, out here. Let's make a big circle. Come on down here. Down here. Let's pretend we have glue on one foot. So your kinesphere is, without moving that 1 foot, all the places you could touch. We have 6 basic vocabulary words in space. So we're going to go through them. Just follow me. Rising, sinking, and closing, spreading, retreating, advancing. Okay. Go through each of the 6 vertices only once, but this time you cannot go through center.
And then
All the way across. Down.
front. And
And then down, because then it goes right to back.
Yes. I like that.
Left. So the first day we covered single spatial tension and the 6 basic vocabulary words of up, down, left, right, and backward and forward. And that when you connect those 6 points, they become the vertices of the octahedron, which means you have the 8 faces.
I think it's better because it deals with everything in a physical and sight-worthy way, like where you can actually see it and experience it instead of having to just work with it. And that's, I'm sorry, but I really like it that way. A lot better. I like to dance too.
The first day we used flags on stiff poles to create broad, sweeping planes. Of course, we always review 1 spatial tension, and then 2 spatial tensions, and then we added 3 spatial tensions. So that means I can go add forward and upward and sideward, and then I get this diagonal line. Opening, sinking, advancing, closing, rising, retreating. Wow! The second day, when we created the cube, by creating the diagonals inside the cube, we also did the diagonal scale, which simply means you're doing the diagonals in a specific order that was been created for us. What's happening here? You
Triangles, lots of triangles.
Okay, but what are these?
Triangles.
What are these?
Diagonals.
Oops. These are the
vertices.
These are the 4 diagonal. No, now where are the vertices in this cube?
Vertices?
Yeah.
Bam, 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 bam.
So in a cube, how many vertices? 8. Right. And where are they?
Corners.
4 corners. Okay. And how many diagonals make 8 corners?
How many diagonals? 4.
There are 4 big diagonals. If we go straight along that in our movement.
I know that I, myself, am a visual learner, learning visually and physically, actually experiencing the things that we open up our textbook and look at daily. It helps to lock it in my memory, and when I go refer back to that textbook and do my homework assignments, I know that now I'll be able to understand them better and have a better idea where the book is coming from.
The second day, we used Chinese ribbons, which followed our trace forms, and we were able to do more complex movements.
Okay, so we have how many planes? How many planes? You guys, 3. And how many corners does each have? So we have how many points if we add them all together? 12. We're going to connect all those 12 points, and we have another scale. Remember, we had the dimensional scale, and then we did the diagonal scale. So today, it's only called the A scale. Forward high 8, table 9, door 10, wheel 11, table 12, and back to the beginning. Part of the geometry standard and part of all math standards in many respects, I guess predominantly is the visualization of three-dimensional space. And one of the requirements of the Minnesota standards and from the National Council of Teachers Mathematics standards is to be able to visualize the three-dimensional representation, to model, and be able to maneuver in that three-dimensional world and to operate that model. What points are they holding?
The door.
The door.
No, that would be sagittal.
Sagittal.
Or
Okay.
wheel.
Okay, so these are the 4 wheel planes: back high, back low, forward high.
From over here, it looks like.
What, but so this person is standing here. Okay, so good, thank you, you guys.
The third day, we created inside the icosahedron the A scale and the B scale using the 12 points in a particular order. We used fabric that was on bendable poles, and that allowed us to really feel the three-dimensionality of the movements that we've been learning.